Welcome to Journey Through Time, a quiet place where history, science, and mystery blend into a single unfolding story. Tonight, we step away from the ordinary and drift toward the edge of the unknown, to Mars, the red planet, whose surface holds some of the most fascinating and debated formations ever discovered. In this serene and immersive journey, you'll be guided through an alien landscape that feels at once distant and strangely familiar. Together, we will wander among shapes and shadows that seem too deliberate to ignore, perfect lines carved into a world shaped by chaos and time. As you breathe deeply and settle in, let your imagination stretch outward, because once you've seen what Mars is hiding, you may never look at it the same way again. As you drift deeper into this journey, picture yourself hovering over the silent plains of Mars, the thin atmosphere tinted in hues of salmon and rust. Below stretches an alien canvas, carved by time, battered by storms, and yet revealing shapes that defy easy explanation. Across the crimson ground lies a ring of massive stones, some upright, some toppled, some leaning precariously, as if caught mid-fall. From orbit, the pattern is unmistakable, a near-perfect circle echoing monuments we know from our own ancient past. The stones appear not as random debris, but as markers, each one separated by a rhythm of space that suggests intention. To see it is to feel the same pull that humans once felt when standing before Stonehenge or the ringed sanctuaries of forgotten cultures. On Earth, circles of stones meant ceremony, observation, or communion with the heavens. What does it mean to find such a shape on Mars, under a sky where the sun rises weaker and the wind whispers through dust rather than grass? Geologists propose impact craters and freeze-thaw cycles as causes, but even they admit the pattern's symmetry is striking. And as your mind lingers over the image, it conjures possibilities. Celestial alignments millions of years old, markers for an extinct species, or a purely natural sculpture whose perfection only mimics design. In that uncertainty lies the power of exploration. Beyond the ring of stones, the Martian surface opens like a book written in an unfamiliar alphabet. Among its pages, the most famous chapter begins in 1976, when NASA's Viking 1 orbiter swept across the northern hemisphere. As cameras clicked, one image emerged that would electrify the world. In the region called Cydonia, shadows pooled across a mesa in such a way that it resembled a human face staring into space, eyes, nose, mouth, and brow arranged with uncanny clarity. Stretched nearly 2 kilometers end to end, this face on Mars became an instant cultural flashpoint. Scientists cautioned that it was merely a trick of light and shadow, a geological feature viewed at the perfect moment. Yet newspapers splashed the image across front pages. TV anchors speculated about ancient civilizations. The public, enthralled by the idea of a carved Martian monument, turned the photo into a symbol of the possibility that we are not alone. Decades later, sharper images under different lighting would reveal a rugged hill rather than a sculpted visage. But by then, the idea had taken root. The face on Mars remains, not as evidence of aliens, but as evidence of our longing for connection. Proof of how quickly the human brain turns stone into story and shadow into myth. Close to the face lies another enigma, the 5-sided D&M pyramid, rising from the dust like a geometric sentinel. In early photographs, its shape was shockingly precise, crisp angles and sharp edges forming a massive pentagon, each side meeting at a point, like some colossal origami. Some analysts measured the structure and found proportions reminiscent of Earth's ancient monuments, claiming alignments to celestial bodies and mathematical constants. To believers, The pyramid and the face together suggested a vast architectural complex, a Martian Giza, built by hands unknown. Geologists countered with their own story. Polygonal hills and mesas are not unheard of in nature, especially when tectonic stress fractures rock into facets later sharpened by erosion. Modern high-resolution images show softer edges and irregularities, where the old photos suggested perfection. Yet even with these explanations, the pyramid retains its mystique. The scale alone, kilometers across, invites speculation. The idea that two such iconic shapes should appear near each other by chance fuels a sense of hidden order, a pattern waiting to be deciphered in the chaos of a planet long dead, or perhaps long waiting. As rovers trundle across Martian soil, new anomalies keep emerging. One of the most haunting appeared in 2022, when Curiosity photographed a small, dark gap in a cliffside, a doorway-shaped opening framed by clean vertical and horizontal lines. Barely 30 centimeters tall, it looked eerily like the entrance to an ancient tomb or a fortress gate, scaled for something other than humans. NASA explained it as a natural fracture, formed by stress and erosion along fault lines. But the precision of its edges and its context within Gale Crater, a site rich with layered history and evidence of ancient water, made it impossible for the public to dismiss. People compared it to the thresholds of Egyptian temples, fortress gateways, even modern homes. In a single frame, Mars appeared not just alien, but inhabited, even if only by memory. The doorway became a symbol of our own desire to cross a threshold, to step from knowledge into mystery. Whether natural or artificial, it underscored a deeper truth. Mars is a planet whose every image feels like an invitation to imagine a bigger story than geology alone can tell. Far above the Martian plains, orbiters have also mapped features that defy our intuitive sense of randomness. Long, smooth ridges gleam pale against darker terrain, twisting across ancient volcanic plains like immense translucent serpents. Nicknamed glass worms, these formations resemble collapsed tubes or channels, their sinuous paths stretching for miles. Scientists attribute them to lava tubes formed billions of years ago, their roofs caved in to reveal glossy interiors of volcanic glass. Yet their reflective surfaces, uniform widths, and graceful arcs give them an almost engineered appearance. On Earth, lava tubes are not only geological marvels, but potential shelters for explorers. On Mars, they could have been lifelines for ancient life, offering protection from radiation and cold. In the absence of close-up exploration, speculation thrives. Were these natural conduits, or the remnants of something built, now weathered into near invisibility? The glass worms remind us that Mars's most compelling mysteries often live in the boundary between plausible science and imagined history, where volcanic geology and ancient architecture might share the same silhouette. And still the anomalies continue. Needle-like spires, known as shards, rising from barren plains, ship-shaped hills etched by time, and even vast hexagonal or grid-like patterns stamped into the crust of the planet. Each new formation carries with it the same push and pull. Between the clean explanations of erosion and the tantalizing pull of a deeper narrative. Shards resemble fragile obelisks, thin and impossibly tall against the salmon sky, as though marking sacred places. Grid formations in regions like Elysium Planitia mimic the outlines of city blocks, straight lines and right angles stretching for kilometers, stirring visions of long-lost Martian metropolises. Even seasonal spiders, at the poles, dark branching shapes that appear when dry ice sublimates in spring, evoke life in motion. Taken together, These features create a portrait of a planet, both alien and hauntingly familiar, a world whose surface is at once a geological record and a canvas for our own hopes and fears. To study Mars is to stand in that liminal space between evidence and imagination, to acknowledge that until we set foot there ourselves, we will always be reading shadows, always searching for meaning in the silence of another world. Beyond the spires and grids, the Martian landscape turns into an atlas of illusions, a place where every shadow seems to whisper a forgotten story. Among the most striking are the so-called skull rocks, photographed by Curiosity and other rovers. In one image, a single boulder juts from the dust, its curves and hollows mimicking the human face's most primal symbol, a skull. Dark pits suggest eye sockets. A broken ridge becomes a jawline. On Earth, such a rock would be dismissed as pareidolia, the brain's habit of seeing faces where none exist. But on Mars, the effect is electric. A skull implies not just life, but death. Not just death, but presence. This eerie familiarity collapses the distance between worlds, making a barren plain feel like an unmarked graveyard. Scientists explain it with erosion, wind carving and fracturing stone over eons, shadows sharpening angles and deepening voids. Yet even with explanations in hand, the image persists. Artists colorize the rock bone white. Conspiracy theorists weave entire Martian civilizations around it, and the public can't quite shake the feeling of being watched. Skull rocks encapsulate the emotional dimension of exploration, the moment when data becomes myth, when pixels carry the weight of an unanswerable question. Beyond skull rocks lie formations even stranger, spires as thin as needles rising from windswept flats, like ancient obelisks defying time. One in particular, dubbed the Shard, stands dark and solitary against ochre dust, tapering to a point, as if carved to signal the heavens. It appears so delicate that it should topple under its own weight. Yet there, it endures beneath a salmon sky, lashed by winds and sealed in cold. Geologists argue the Shard is the last remnant of a larger rock mass, the toughest pillar left behind after softer stone eroded away. But its lonely elegance calls to mind the obelisks of Egypt or the stelae of forgotten cultures. On Earth, such monuments marked boundaries, celebrated rulers, aligned with stars. On Mars, the Shard evokes the same symbolism, even as it resists direct explanation. Without a scale reference, it could be meters or mere inches tall. Without touch, its texture could be jagged or smooth as glass. This ambiguity fuels fascination. The Shard is not just a shape in rock. It is a mirror for our instinct to assign meaning, a needle stitching together science and myth. From high orbit, other features echo this tension. There is the so-called shipwreck, a long curved formation whose profile recalls a vessel stranded in a dried-up ocean. From one angle, it appears to have a bow, a stern, even a suggestion of a deck half buried in sand. The resemblance is powerful because Mars once held water, lakes, rivers, perhaps even seas, so a shipwreck seems plausible in the imagination. Scientists counter with a catalog of erosional processes, wind scouring, freeze-thaw cracking, and low-angle sunlight creating deceptive shadows. Still, the illusion persists because it intersects geology with narrative. Where there was once water, the mind invents sailors. Where there is a curved ridge, the mind invents a hull. In this sense, Mars acts as a vast Rorschach test for planetary curiosity. Every ridge becomes a temple, every hollow a tunnel, every curve a memory of life. The shipwreck image stands as a case study in how exploration is shaped not just by technology, but by the stories we bring with us, and how even the coldest data can conjure visions of odysseys that never were. The deeper scientists look, the more geometry they find. One plateau shows a tessellation of hexagons, so neat it resembles floor tiles laid by an invisible hand. Another region, Elysium Planitia, appears crisscrossed by straight ridges and right angles, like the skeleton of a vanished city grid. These patterns have scientific explanations: contraction fracturing, cooling lava, tectonic stress. But their regularity invites speculation about roads, fields, or foundations long lost. On Earth, natural hexagons form at the Giant's Causeway or in dried lake beds. Polygonal fractures etch ice sheets in Antarctica. Yet the Martian versions carry an extra charge because of where they are and how we see them. From far above, stripped of context, rendered in high contrast light. In these images, chance and intention look almost indistinguishable. Even planetary geologists, while skeptical of alien architects, admit the visual harmony is captivating. It keeps the public interested, draws new eyes to old data, and sometimes even leads to genuine discoveries when anomalies turn out to reveal overlooked processes. In this way, Mars's mysterious patterns perform a dual function. They are both real geology and powerful storytelling engines. Finally, in the frozen south, the planet reveals one of its strangest seasonal performances, the so-called spiders of Mars. As winter loosens its grip, sunlight penetrates the translucent layer of carbon dioxide ice blanketing the pole. Gas trapped underneath builds pressure until it erupts upward, blasting dark dust across the surface in branching trails. From orbit, these marks resemble the bodies and legs of enormous arachnids crawling through frost. They are not living creatures, but jets of gas, carving ephemeral patterns that fade and return with each Martian year. Yet their organic appearance is so striking that people instinctively attribute agency to them. The spiders make Mars feel active, breathing, alive in cycles we can watch, but not touch. They are a reminder that even without liquid water or lush ecosystems, a planet can still pulse with seasonal energy, painting its own alien calligraphy across the ice. In their beauty and strangeness, the spiders embody the essence of Martian mystery, familiar shapes in an unfamiliar context, fleeting yet enduring, mechanical yet seemingly alive. They close the circle begun by the stone rings, the face, the pyramid, and the doorway, a world forever poised between the known and the imagined. As the orbiters and rovers send back more and more data, Mars begins to resemble a vast museum whose exhibits are arranged not by intention, but by time itself. Every anomaly, whether a spiral mound or a hexagonal plateau, is a fragment of the planet's autobiography. Yet what makes these fragments so powerful is not only their strangeness, but the way they resonate with human history. The stone circles call up megalithic sites. The pyramids evoke Egypt. The shards echo obelisks. The grid-like ridges mirror our own cities, seen from above. This resonance invites a kind of emotional archaeology. When we look at Mars, we're not just seeing a planet. We're seeing ourselves, projected outward across millions of kilometers. This reflex is both a strength and a trap. It allows us to generate hypotheses, but it also tempts us to imagine builders where there were only forces of wind, ice, and fire. Even the most disciplined scientist feels the pull, if only for a moment. That quick jolt of recognition when a formation's shadow matches the geometry of memory. Mars becomes not just an object of study, but a psychological mirror, revealing how deep our yearning runs for contact with something ancient, intelligent, and other. This yearning extends beyond formations into color itself. Among the ochre plains and rusted cliffs, Orbiters have revealed splashes of vivid blue, electric turquoise patches against the red dust. Scientists attribute these colors to frost, to mineral deposits, to false color imaging designed to highlight composition. But the public calls them blue oases and imagines hidden reservoirs, secret lakes shimmering beneath the thin atmosphere. On Earth, blue almost always signifies water, the ultimate symbol of life. When blue appears on Mars, it feels like a promise or a revelation, even when science says otherwise. This interplay between expectation and evidence drives much of Mars's allure. Each photograph is both a measurement and a Rorschach blot. We see water where there is only ice, life where there is only geology, design where there is only erosion. And yet, paradoxically, this instinct keeps exploration alive. If we only ever saw dust, we might lose interest. But because we glimpse what might be, even fleetingly, we continue to look, to send missions, to plan for human footprints on red soil. In this way, the blue oases, like the face or the pyramid, become landmarks not just on Mars, but in our collective imagination. One of the most striking examples of this psychological mirroring is the case of the Twin Peaks. Discovered in the hazy horizon shots of Mars Pathfinder in 1997, these two hills stand like sentinels on an otherwise flat plain. Their near-identical profiles, slopes, and heights suggest a symmetry rarely seen in nature at such scale. Geologists propose they are remnants of a single larger formation, split and eroded over time, or volcanic cones born from the same hotspot. But to the public they are something else. Gateposts, twin pillars, the entrance to a vanished world. Across cultures, twin structures carry symbolic weight, from the Pillars of Hercules to temple doorways, from myths of duality to stories of thresholds. The Twin Peaks activate this archetype with startling clarity. They seem to lean toward each other, framing a shallow valley between them, a natural corridor leading nowhere. From the rover's perspective, the valley floor is strewn with stones, but from orbit, the peaks look like watchtowers guarding a lost road. This duality, mundane geology versus monumental meaning, is at the heart of the Martian experience. Each feature is both itself and a cipher, a place and a possibility, a rock and a story. Even seasonal change becomes a theater of mystery on Mars. At the South Pole, as winter recedes, carbon dioxide sublimates and jets of gas carve spider-like trails into frost. But elsewhere, in equatorial regions, spring and summer bring dust devils, towering columns of swirling particles that sweep across the plains like silent tornadoes. Rovers have captured these moving ghosts on camera, their shadows racing over the surface, sometimes miles high, yet delicate as silk. Dust devils leave behind dark tracks that can crisscross a region in geometric patterns, erasing and redrawing themselves with each passing season. To the human eye, these tracks can resemble ancient roads, runways, or messages etched into the soil. In reality, they are the fingerprints of an active atmosphere, but they add another layer to Mars's ever-shifting map of illusions. Taken with the spiders, the blue oases, and the Twin Peaks, they create the impression of a planet alive, not with organisms, but with processes, a world still sculpting itself under a thin, alien sky. In this ongoing play of light, motion, and form, Mars refuses to be static, reminding us that even the dead planets are still breathing in their own slow rhythm. High above all these surface puzzles orbit Phobos and Deimos, Mars's two tiny moons. Phobos in particular has sparked its own mythology, thanks to the monolith, a tall, sharply defined object, casting a long shadow across the moon's battered surface. When astronaut Buzz Aldrin casually mentioned it in an interview, saying, "Who put that there?" the world took notice. The monolith resembles the alien slab from 2001, a space odyssey, so closely that speculation was inevitable. Scientists call it just a boulder, preserved by low gravity and lack of erosion, but its isolation and geometry make it look deliberate. Like the anomalies on Mars, the Phobos monolith represents a convergence of pattern and desire, a place where our expectations of space exploration collide with our myths about alien contact. Its presence on a moon, doomed to eventually crash into Mars or shatter into a ring, only adds to its allure. A lone sentinel, orbiting a world of riddles, destined to fall, yet still holding its secrets. Taken together, these formations form more than a catalog of curiosities. They trace a pattern of human engagement with the unknown. Every anomaly begins as a photograph, a pattern of pixels. Scientists measure angles, study spectra, model erosion. The public stares, compares, speculates, and dreams. The cycle repeats: discovery, excitement, explanation, lingering doubt. In this cycle, we see not just Mars, but ourselves, our cognitive wiring, our cultural myths, our hunger for significance in the void. Mars acts as a blank canvas for our projections. Where we find circles, we imagine rituals. Where we find hexagons, we imagine cities. Where we find a simple boulder standing alone, we imagine a monolith planted by hands, beyond our understanding. This doesn't mean the anomalies are meaningless. It means they are doubly meaningful, as geological features and as psychological triggers. They reveal both the planet's deep past and our own inner landscape, showing how exploration is as much about the explorer as it is about the explored. This psychological dimension extends into the future of exploration. As missions plan for human arrival on Mars, engineers consider the same features that capture public imagination as potential resources. Lava tubes could become shelters for astronauts, shielding them from radiation and dust storms. Polar ice could provide water. The very formations we romanticize as ruins or monuments might one day serve as habitats, laboratories, or waypoints for human activity. In this way, the myths we spin today could become the infrastructure of tomorrow. By mapping every anomaly, every unusual ridge and hollow, we are not only satisfying curiosity, but laying the groundwork for survival. Mars thus becomes both a dream and a blueprint, a place where our stories and our science converge to create a future. The ring of stones, the doorway in the cliff, the shard on the plain. Each could be nothing more than rock and shadow, yet each could also be the first landmark on a new human world. In the end, what Mars offers us is not simply answers, but a sustained encounter with mystery. Each new image from a rover or orbiter is a question mark carved into red dust, an invitation to wonder. We may find that the face is a hill, the pyramid a mesa, the monolith a boulder. We may trace every glass worm to lava, every spider to sublimating ice, every blue oasis to minerals and frost. Yet even then, the allure remains. Because behind each explanation lies the deeper thrill of reaching across space to touch another world, of seeing familiar shapes in alien terrain, and feeling, if only for a heartbeat, that we are not alone. Mars will continue to draw us with its paradoxes, barren yet patterned, silent yet eloquent, dead yet alive with questions. And as long as it does, we will continue to journey through time and distance, exploring not only the red planet, but the hidden terrain of our own imagination. If you could hover just above Mars, slowly gliding over its vast plains and endless craters, the planet would begin to unfold beneath you, not as a simple red desert, but as a living atlas of mysteries. Beneath the salmon-colored sky, entire regions reveal themselves as patterns so large they are only visible from orbit, ridges stretching for dozens of kilometers, spirals curling across frozen ground, and fractures carving the crust into perfect geometric grids. As your eyes adjust, the surface stops looking like a wasteland and begins to resemble the blueprint of some colossal, long-abandoned project. The skeleton of a world that once lived by rules we no longer understand. Every ridge becomes a street, every plateau a foundation, every shallow depression a courtyard, and every spire a watchtower. This is not because the planet is actually built that way, but because the human mind, deprived of familiar references, begins to weave narrative from chaos. It's the same impulse that allowed our ancestors to see constellations in random stars, gods in storms, and spirits in forests. On Mars, that impulse meets a perfect stage, a vast, silent expanse shaped by forces so slow and immense they become indistinguishable from intention. In the far north, the so-called hexagonal plateau spreads like a cracked tile floor across the land. Up close it would be rough, dusty, fractured rock, but from orbit it forms a honeycomb geometry so consistent it appears deliberate. Each cell is big enough to swallow a skyscraper. Each line is a stress fracture preserved over geological ages. And yet, as the image scrolls across your screen, it's impossible not to see a giant courtyard or a landing platform, the base of something whose superstructure has long since vanished into dust storms. Not far away, an area of interlocking ridges forms what looks like a grid of streets and avenues, as if a city had been erased, but its street plan remained. Scientists map the stresses, measure the angles, compare them to volcanic and tectonic analogs on Earth. But the public sees neighborhoods, districts, perhaps even a metropolis fossilized in rust. This duality between data and dream is where Mars thrives. In the southern highlands, seasonal eruptions beneath translucent carbon dioxide ice create the Martian spiders, black tendrils radiating outward, like ink dropped in water. From orbit they resemble living organisms, colossal arachnids crawling over the pole, appearing and vanishing with the seasons as though breathing. Scientists know the physics: sunlight warming ground under ice, gas building pressure, dust bursting upward. But knowing the mechanism does not erase the shock of the image. It looks alive, and that alone is enough to jolt the imagination. In the equatorial plains, dust devils carve looping tracks across the surface. Over time, these tracks crisscross, overlap, and fade, creating an ever-changing calligraphy. Stand there, and you would hear nothing but a faint hiss of dust against rock. Watch from above, and you might believe you were seeing the trails of machines or animals wandering over a desert floor. Then there are the formations that seem to reach up toward the thin sky. The shard, a dark needle of stone, clusters of delicate spires like broken cathedral towers, and solitary boulders casting shadows so tall they resemble monoliths in a sea of rubble. Each one raises the same question: how did this survive? On Earth, wind and water would topple such structures in millennia, but Mars is a slow sculptor. Its air is thin, its water long gone, its processes glacial. A spire here can stand for millions of years, balanced like a secret on the brink of disclosure. Their persistence makes them look chosen, set apart, preserved on purpose. The glass worms twist across volcanic plains, pale ribbons against dark rock. Their smooth, consistent widths and sinuous curves hint at something beyond random collapse. The leading hypothesis is lava tubes, their roofs caved in, exposing volcanic glass that gleams under sunlight. but seen from orbit, they look like arteries or tunnels, conduits for something once flowing beneath the surface. On Earth, lava tubes are prime real estate for explorers, safe from radiation and storms. On Mars, they could have sheltered life or hidden relics of a bygone epoch. We have no rover inside them, no high-resolution scan of their interiors. They remain lines on a map, unvisited corridors in a planetary ruin. And then, scattered across multiple regions, patches of electric blue shimmer like hidden lakes under a sunset sky. Scientists say minerals, frost, and image processing. The public says water, oases, life. Both are right in their own way. The blue patches really are special. They mark fresher ground, mineral diversity, and subtle variations in temperature. They also mark our craving for color, our instinct to seek signs of the familiar in the alien. In a desert world, blue is hope, and hope is hard to dismiss. As your mental journey continues, imagine you're descending through thin Martian air toward the Twin Peaks, those paired hills Pathfinder saw in 1997. They rise like two hands from a buried giant, fingers pointing at the pale sky. Between them stretches a shallow valley littered with stones, a corridor that feels like a gateway, though it leads nowhere. They are probably the product of erosion, perhaps two remnants of a once larger mound split apart. Yet they look like guardians, like pillars framing an invisible door. This is how the human brain works. It takes erosion and calls it architecture, takes geology and calls it history, takes chance and calls it destiny. Now picture the Phobos monolith, standing alone on Mars's battered moon. It's probably a boulder thrown by some ancient impact, its edges preserved by low gravity and lack of atmosphere. But it also looks like a message, a marker, a sentinel orbiting a world full of secrets. Buzz Aldrin's offhand remark, "Who put that there?" is a reminder that even astronauts, trained in engineering and discipline, are not immune to the thrill of the unknown. The monolith is a metaphor as much as an object, a stand-in for every unanswered question about Mars and ourselves. Pull back farther still. From this vantage, Mars is a sphere of contradictions, frozen yet restless, barren yet patterned, silent yet eloquent. Its anomalies, rings, faces, pyramids, shards, grids, worms, spiders, monoliths, are not isolated curiosities, but chapters in a single ongoing dialogue between a planet and its observers. Every new image adds a verse to this poem. Some lines are written by wind and ice, others by our imagination. Together they form a tapestry that refuses to resolve into simple answers. This is why the mystery endures. We will map every crater, analyze every ridge, send rovers to sniff every pebble, and still Mars will hold back something, an ambiguity at the edge of perception. It's not deception, it's scale. The planet is too large, too old, too subtle for our quick conclusions. Like all great mysteries, it feeds us just enough to keep us searching. In that search we find ourselves, our patterns, our myths, our need to find meaning. The ring of stones, the face in Cydonia, the D&M pyramid, the doorway in Gale Crater, the shard, the glass worms, the blue oases, the Twin Peaks, the Phobos monolith. Each one is a mirror reflecting our hopes and fears as much as it reflects sunlight across the Martian dust. In this way, Mars is not just a planet, but a stage on which we rehearse our oldest story. The story of discovery and wonder, of seeing the other and finding ourselves. As you drift over the rust-colored plains, your mind filled with images of alien monuments and natural marvels, you realize that the real journey is not from Earth to Mars, but from certainty to curiosity. The further we travel, the more we understand how much we do not know. And that, perhaps, is the greatest gift Mars gives us. Not proof of life or ruins or monuments, but an ever-renewed invitation to explore. Imagine drifting lower, skimming just above the fractured ridges of Elysium Planitia. From orbit, the region looks like a city plan, etched into stone. Straight ridges crossing at right angles, long corridors carved by tectonic stress. The rational explanation is simple. Cooling lava cracked, erosion deepened the seams, and shadows exaggerated the geometry. But standing here, if you could, it would feel uncanny. The lines stretch on for kilometers, some parallel, others intersecting at almost perfect 90-degree angles. They form blocks, squares, rectangles, shapes that echo our own designs. Cities, after all, are nothing more than geometry imposed on land, and here, nature has beaten us to it. From this vantage, you might imagine streets bustling with beings long gone, structures now eroded to nothing, foundations swallowed by dust. The rational part of you whispers, geology. The imaginative part shouts, ruins. And in this tension, Mars reveals its true power. It is not what is there, but what it makes us see. Scientists map the fractures, chart their distribution, and trace their origins to stress in the planet's crust. They publish papers on contraction and tectonic faulting. Yet even they admit the alignments are visually arresting. The human brain cannot resist the illusion of intention. This is why the Elysium grids remain a touchstone in discussions of Martian anomalies. They are a reminder that sometimes nature creates patterns so perfect we mistake them for blueprints of civilizations that never were. Shift now to the high volcanic plains where the glass worms writhe across the surface. They glisten under sunlight, pale ribbons etched into darker terrain. To the scientific eye, they are collapsed lava tubes, the remnants of flows that hardened on the outside while molten rock continued to surge inside. Over time, the roofs caved in, leaving behind the gleaming scars we see today. But to the human eye, especially when seen in orbital photographs, they resemble conduits, tunnels carved for transport, arteries of an ancient machine, or even the fossilized remains of something alive on a scale too vast to comprehend. These structures stretch for miles. Some curve gently like rivers, others run straight like engineered channels. Their consistent width adds to the illusion of design. On Earth, lava tubes can be small, sometimes only wide enough for a human to crawl through. But on Mars, with lower gravity and vast eruptions, these tubes could span hundreds of meters. If you were to walk through one intact, you might feel as if you were inside a cathedral, roof arched high above, walls shimmering with volcanic glass. They would make perfect shelters for explorers, natural bunkers against radiation. Scientists have already suggested this possibility for future colonies. In this way, the glass worms bridge myth and practicality. They are at once relics of ancient geology and possible homes for future humanity. What once looked like alien infrastructure may someday become our own. Turn your gaze to the polar regions, where the spiders awaken. Each Martian year, as sunlight strengthens, jets of carbon dioxide explode from beneath translucent ice. The result is an alien fireworks show carved into frost, dark veins, branching lines, spreading outward like enormous insects etched across the surface. The first time orbiters photographed them, scientists themselves were startled. They looked alive. They looked like colonies spreading, organisms crawling across frozen ground. Explanations came quickly, but the images lingered in memory. The spiders are perhaps the best example of how Mars plays tricks on perception. They are real processes, fully understood, yet they look like something else entirely. Something living, something purposeful. Standing on the ground during such an eruption would be otherworldly. The air would be silent, too thin to carry much sound. The only evidence of eruption would be a plume of dust rising like smoke, settling into branching trails. Each season the patterns renew themselves, erasing old marks, writing new ones. They make Mars feel alive not with biology, but with geology so active it masquerades as life. For many, the spiders are more fascinating than monuments or pyramids because they are happening now. They are not relics of the past, but performances of the present, reminders that even in a thin, freezing atmosphere, the planet still breathes. Now travel to the myths we project onto Mars. For centuries, long before spacecraft, humans imagined canals on its surface, engineered waterways crisscrossing the planet. Telescopes in the 19th century revealed faint lines, and astronomers like Giovanni Schiaparelli and Percival Lowell mistook them for structures. They believed Mars was a dying world, its inhabitants digging canals to preserve dwindling water supplies. The canals were illusions of optics, but they captured the imagination so deeply that they shaped science fiction for generations. Burroughs, Bradbury, Clarke all wove stories of Martian civilizations into their works. Today, we know there are no canals, yet the same instinct persists. The ring of stones, the face, the pyramid, the grids, each new discovery echoes the canal myth. We see intention where there is randomness, survival where there is erosion. The legacy of the canal era teaches us something profound, that Mars has always been a screen for our projections. We see not just what is there, but what we wish to be there. This is why anomalies captivate us. They keep alive the ancient dream that Mars is not merely a neighbor, but a mirror, a place where our deepest hopes and fears take shape. Finally, lift your eyes to the horizon, where two mountains rise in symmetry, the Twin Peaks. Their shapes are nearly identical, their slopes etched with gullies, their summits leaning slightly, as if in silent conversation. From orbit, they look like reflections. From the ground, like guardians. Scientists see remnants of erosion or volcanic activity. Dreamers see pillars, gateways, monuments. Across cultures, twin structures mark thresholds, the passage from one realm to another. The pillars of Hercules flanking the Strait of Gibraltar symbolized the edge of the known world. Temple gates in Asia framed sacred spaces. Twin towers in myths often represented balance, duality, and passage. On Mars, the Twin Peaks trigger the same archetypes. Pathfinder's tiny rover once photographed them from afar, their hazy outlines rising above a dusty horizon. The images made their way into textbooks, newspapers, and even artwork. People speculated about lost cities, giant monuments, even cosmic signposts. None of it is proven, yet all of it is powerful. The Twin Peaks remind us that exploration is not just about facts, but about meaning. We project onto them our archetypes of entry and guardianship. Whether natural or otherwise, they stand as a gateway, not to an ancient Martian city, but to the human imagination itself. The deeper you sink into this imagined flight over Mars, the more the planet stops being a map and starts being a myth. Far below, in regions rarely photographed in detail, the land folds into spirals, twists into ridges, and splinters into labyrinthine channels. From a great height, it feels as if you're looking down on a fossilized ocean, wave upon wave, frozen mid-motion. The spiral mounds are the most dramatic. They curve inward on themselves in precise arcs, each ring nested within the last, like a giant ammonite carved into the crust. Some are kilometers across, their ridges standing higher than city skyscrapers. Others are delicate, their spirals so fine they resemble fingerprints pressed into dust. Scientists compare them to lava spirals or glacial moraines formed by flows of molten rock or ice billions of years ago. But their consistency across widely separated regions raises questions. How could such perfect symmetry arise again and again in so many places? Could some underlying planetary process, unseen on Earth, be at work beneath the Martian crust, shaping land according to hidden equations? Or are we looking at something more extraordinary? The remnants of patterns created intentionally, on a scale too large for individual structures, a kind of planetary art? Spirals have always fascinated humanity. They appear in shells, galaxies, hurricanes, and in sacred art from the Neolithic to the present. On Mars, they carry the same archetypal charge. They are nature's most efficient pattern, the geometry of growth and flow. Seeing them embedded in rock makes the mind leap to life, to civilization, to design. Imagine standing at the base of one of these spirals. The sky above is pale pink, the horizon dusty and endless. The air is so thin your breath would vanish as vapor, the temperature colder than Antarctica's worst nights. Yet underfoot, the ground curves in a path so smooth you could follow it as a road, walking its coils toward a center you cannot see. Each ridge rises like the rim of an amphitheater. Each trough descends like a step in a colossal staircase. It feels as if you are inside a symbol, walking through a sign left behind for an audience that may never arrive. The silence is absolute. Only the low hiss of dust sliding off your boots would mark your passage. From orbit, the spirals are even stranger. Some seem to connect to subterranean voids or lava tubes. Others end abruptly at cliffs or disappear beneath dunes. A few appear to align with ancient impact sites, as though the energy of collisions had imprinted rotational patterns on the crust. None of this is proven, but all of it feeds the speculation that the spirals are not isolated, but linked to Mars's deepest history. A history that may include oceans, glaciers, or forces unknown. Just as the canals of the 19th century fired imaginations of engineers and explorers, the spiral mounds fire imaginations of geologists and dreamers alike. They are puzzles with no answer yet, beautiful precisely because they resist our need for certainty. Pull back farther still, and the planet's surface becomes a gallery of paired and repeated shapes. Twin peaks, twin craters, parallel ridges, mirrored escarpments. Some of these symmetries are easily explained by impact or tectonic activity. Others feel uncanny. On Earth, symmetry usually signals life. Paired organs, bilateral creatures, mirrored leaves. In landscapes, symmetry is rarer, more likely to be read as a sign of deliberate shaping. On Mars, symmetrical landforms activate the same recognition circuits in our brains. They whisper of design, of hidden order, of a hand we cannot see. This whisper is why the anomalies endure, not because they are evidence of life, but because they are evidence of our hunger for life. And yet the scientific narrative is no less fascinating. By mapping these patterns, researchers reconstruct Mars's climate, its volcanic past, its polar cycles, and its tectonic stresses. Each anomaly, even if natural, becomes a key to a larger system. The ring of stones hints at impact mechanics. The pyramids and mesas reveal how wind sculpts layered rock. The spirals expose flows of lava or ice. The spiders map the movement of seasonal CO2 beneath translucent frost. Far from diminishing wonder, these explanations deepen it. They show that Mars is not static, but dynamic, a planet still reshaping itself, even in its apparent dormancy. This duality, geology and mythology, is why Mars remains such a powerful focus for exploration. It is not simply another rocky world. It is a psychological landscape, an arena where our craving for pattern meets the raw indifference of a frozen desert. Each new mission adds pixels to our picture, and yet enlarges the mystery. Higher resolution shows more details, but also more illusions. Shadows sharpen, angles align. What once looked like randomness now looks like a message, and the cycle begins again. In this sense, the Martian anomalies are as much about us as they are about Mars. They are the record of how a species reads the universe, looking for itself in the stars and finding faces in the clouds of another world. Imagine future explorers walking among these formations. They set foot on the hexagonal plateau, descend into a glass worm, stand at the base of a towering shard. Their boots kick up dust that hasn't been disturbed in eons. They touch stone that may be purely natural, but feels charged with significance. Perhaps they plant instruments, drill cores, measure isotopes, and confirm geological origins. Perhaps they find something unexpected, a fossil, a trace of ancient microbial mats, a structure that cannot be explained by geology alone. Either way, the act of presence changes the equation. Seeing with human eyes, feeling with human hands, will resolve some mysteries and create new ones. Until that day, the orbiters keep circling, their cameras catching ever more exquisite glimpses. Data streams to Earth, is rendered into images, and the images into stories. The cycle of wonder continues. In this way, Mars is not just a planet, but a process. A slow unfolding of questions that link our past myths to our future explorations. It stands as a reminder that the universe is richer than our categories, stranger than our fictions, and more patient than our lifetimes. As our imaginary flight continues, Mars slowly reveals itself not just as a set of anomalies, but as a complete story, a narrative written in dust, stone, and ice. To understand the present planet, you must imagine its past, a world with rivers and deltas, perhaps even seas, with a thicker atmosphere and a magnetic field once strong enough to shield it from the sun. Billions of years ago, its surface may have been a patchwork of lakes, glaciers, and erupting volcanoes. Into that environment, time carved layer upon layer of rock, freezing snapshots of epochs we can only guess at. When the air thinned and the water retreated underground or boiled into space, the landscapes fossilized, preserving their shapes like insects trapped in amber. This is the stage on which today's anomalies play out. They are not accidents, but residues, echoes of forces that once reshaped the planet on a scale we can hardly fathom. In Valles Marineris, the largest canyon system in the solar system, the scale dwarfs human comprehension. It stretches more than 4,000 kilometers, as wide as an ocean, and as deep as the Grand Canyon multiplied by 10. Along its walls lie strata that record Mars's history like pages of a book, layer after layer of sediment, volcanic ash, and frost. If you hover over its depths, you see shadowed alcoves, isolated mesas, and ridges like battlements. Some cliffsides display clean terraces as if carved by tools. Others collapse in spirals, reminiscent of giant amphitheaters. Scientists map fault lines and landslides, but the human eye sees fortresses, stairways, and forgotten citadels. This canyon alone could hold every anomaly found so far and still leave room for surprises. Its immensity forces you to think in planetary terms, where a single landslide could bury Manhattan, and a minor fissure could be a canyon deeper than the Alps. Elsewhere, Mars's volcanic provinces tell another chapter. Olympus Mons, the largest volcano in the solar system, towers 21 kilometers above the plains, its base sprawling wider than France. Along its flanks lie collapsed lava tubes, radial channels, and peculiar terraces. Some appear so regular in orbital images that they evoke step pyramids, ziggurats, or massive ramparts. When we label them natural, it's not to dismiss them, but to honor the planet's power to sculpt on such a scale. Wind, ice, lava, and time. These are the architects of Mars. Yet their creations so often mimic human forms and structures that our imaginations ignite without conscious effort. Consider also the pit craters and skylights, circular openings that puncture the Martian crust, sometimes leading into dark voids below. They may be entrances to lava tubes or collapsed chambers, but to the human eye they are doorways, wells, and caverns. The thought of hidden spaces beneath the surface, protected from radiation and dust storms, stirs visions of underground life, either past or present. Scientists themselves hope to explore these pits as potential habitats for microbes or future astronauts. Each hole photographed from orbit becomes a portal for speculation. What lies in the darkness beneath? Ice, fossils, entire networks of tunnels. The absence of information becomes an invitation to wonder. Even the planet's color palette deepens the narrative. We think of Mars as red, but in high-resolution images, it is streaked with greenish dust, bluish frost, golden dunes, and black volcanic sands. Dunes migrate over time, forming ripples as precise as any sculptor's chisel. Frost etches delicate patterns at dawn, evaporating by afternoon. Shadows stretch and retract with the low sun, casting monuments where there are none. This constant interplay of light and matter creates a theater of illusions. Every hour of Martian daylight redraws the map of shapes and shadows, creating new faces, pyramids, and doorways for cameras to capture. Look now to the future. Human explorers, landing near one of these anomalies, would experience a sensory overload. The sky thin and salmon-colored, the horizon deceptively close, the ground underfoot crunching with frozen dust. They would be geologists and poets at once, measuring and marveling in equal measure. Perhaps they descend into a lava tube and find walls lined with crystalline deposits sparkling like a hidden cathedral. Perhaps they set up instruments on a plateau, once mistaken for a pyramid, and record seismic tremors, hinting at something deep below. In doing so, they would transform myths into data, but they would also create new myths. The first footsteps at the edge of the doorway, the first night slept inside a glass worm, the first sunrise watched from atop the shard. These acts would echo through culture just as the Viking and Pathfinder images did, but on a scale magnified by direct experience. Mars in this vision becomes not a static world, but a dynamic arena where human perception, science, and myth intersect. Each anomaly, whether natural or artificial, becomes a threshold between past and future, between known and unknown, between imagination and evidence. When we finally cross that threshold, our perspective on both Mars and ourselves will change forever. The rings of stones, the spirals, the grids, the spiders, the blue oases, the twin peaks, the Phobos monolith. Each is a fragment of a greater mosaic, a picture we are only beginning to see. And even if every one of them proves to be purely geological, their real significance may be in how they prepared us to look deeper, to expect wonder, and to embrace the unknown with open eyes. Move now into the deepest time of Mars, the epoch before the thin sky, before the iron dust choked the atmosphere. Picture an ocean stretching across the northern lowlands, ice caps swelling and retreating, rivers carving deltas hundreds of kilometers wide. In this ancient world, volcanoes erupted with a fury unknown on Earth, throwing lava into valleys that cooled into tubes longer than entire mountain ranges. Glaciers ground their way through canyons, leaving moraines and ridges that we now mistake for walls and corridors. Impact craters filled with water, then silted up, then froze, then cracked, leaving polygons like the floor tiles of an abandoned hall. Each of today's anomalies is a residue of that era. The ring of stones could be the rim of a vanished lake, its sediments now eroded into boulders. The pyramids and faces are mesas, whose layers tell of alternating wet and dry climates. The glass worms are collapsed conduits where water once surged. The spiders are eruptions of trapped gases beneath seasonal ice. The blue oases are mineral deposits marking ancient springs. The grids are fracture networks in cooling lava or dried mud. To stand on Mars today is to stand on a stage after the play has ended, props scattered, scenery half collapsed, but the script still visible in the dust. Yet knowing this does not dim the wonder. On the contrary, it deepens it. It tells you that the forces which shaped Mars were vast enough to create structures rivaling our myths. It tells you that nature itself, given time and freedom from life's chaotic overlay, tends toward grandeur and symmetry. We do not need an alien civilization to explain the beauty of these forms. The universe already provides that beauty in abundance. This realization is humbling. It shifts the question from who built this to what process made this, and then to what does it mean that our minds see architecture in erosion. Imagine flying along the lip of Valles Marineris again, but this time not as a tourist, but as a scientist with instruments. Spectrometers sniff the minerals of the cliff walls. Radar pings the hidden layers beneath the sand. Seismographs listen for Marsquakes. Each measurement peels back a layer of history. In one place, you find salts indicating an evaporated sea. In another, sulfates hinting at ancient hot springs. In another, clay, a sign that water lingered long enough to alter rock. Each discovery reshapes the timeline. Mars is no longer just the red planet, but a palimpsest of climates, a record of change written on a planetary scale. And still the mysteries remain. Why do some mesas form perfect pentagons, while others crumble at random? Why do certain dunes migrate in patterns mimicking crop circles? Why do parallel ridges persist across hundreds of kilometers? The models are incomplete. Perhaps something in Mars's interior still stirs. Slow convection, hidden aquifers, unknown cycles of freezing and thawing. Perhaps we're seeing the aftermath of catastrophes so old their traces are subtle but immense. These questions give Mars its enduring power. The anomalies are not just curiosities. They are research agendas waiting for the next generation of explorers. Finally, picture the human response to all this when we land. We will name features after our myths, just as we did with Olympus Mons, Phobos Mons, and Elysium Planitia. We will build habitats near lava tubes and call them after ancient cities. We will climb spires and leave plaques, stand in doorways, and broadcast home. The first footprints on the edge of the doorway in Gale Crater. The first drone flight through a skylight into a lava tube. The first trek along a spiral mound. These acts will transform anomalies into milestones. Mars will no longer be a place of remote images, but of lived experience. And in doing so, we will weave ourselves into the planet's story, becoming the latest layer in its long history. Think now about the psychological dimension of this entire saga. For over a century, Mars has been a canvas for our collective imagination. In the 19th century, we drew canals. In the 20th, we saw faces, pyramids, and monoliths. In the 21st, we track spiders, glass worms, and doorways. Each generation projects onto the red planet the dreams and fears of its time. As technology improves, the details sharpen, but the impulse remains. We want Mars to be alive, to hold secrets, to reflect us. Even when science proves an anomaly to be natural, the fascination lingers because the image has already imprinted on our minds. This cycle reveals something profound about how humans explore. We are not passive collectors of data. We are storytellers. We do not simply see, we interpret. On Mars, with no vegetation or cities to anchor scale, the terrain becomes abstract. Hills turn into faces, cliffs into pyramids, shadows into doorways. The brain seeks order, and in seeking, it creates. This is not a flaw, but a feature. It's how hypotheses are born. Without imagination, we would not send missions at all. The face on Mars led to decades of debate that sharpened imaging technology and spurred public interest. The canal myth birthed science fiction that inspired engineers who built real spacecraft. Even our errors produce progress. Looking ahead, this interplay between science and imagination will shape how we colonize Mars. We will choose landing sites not only for safety, but for symbolism. We will orient habitats to capture sunrise over famous formations. We will build observation decks over anomalies. The myths we create today will become tourist destinations tomorrow. Already, mission planners talk about lava tubes as habitats, polar ice as resources, and ancient deltas as sample return sites. The line between anomaly and infrastructure is thin, but perhaps the greatest gift Mars offers is a mirror. As we pore over images of its anomalies, we're also studying our own cognitive architecture, how we find meaning, how we weave stories, how we project ourselves into the void. This self-reflection is as valuable as any rock sample. It shows that exploration is not just about reaching new worlds, but about expanding the interior landscape of the human mind. At the same time, we must cultivate humility. The history of Mars is a cautionary tale about overinterpretation. For every face, there is a mesa. For every pyramid, a hill. For every doorway, a fracture. Recognizing this does not destroy wonder, but refines it. It reminds us that the universe is under no obligation to match our expectations. What it offers instead is far richer. Complexity, ambiguity, and beauty without agenda. In the end, whether Mars holds evidence of life or not, whether its anomalies are natural or artificial, the red planet stands as a testament to our species' hunger for the unknown. Each photograph, each map, each whispered rumor of a structure on its surface is an invitation. And each invitation leads us back to ourselves, to our capacity for awe, to our resilience in seeking answers, to our willingness to be surprised. Mars will continue to evolve in our understanding, and so will we. This ongoing dialogue is the real story, larger than any single formation or discovery. And as you drift one last time over the spirals, the grids, the spires, the blue oases, the monoliths, you realize that this journey is not ending but beginning. The planet will still be there tomorrow, waiting, silent, vast, and patient. Its mysteries will outlast our lifetimes, but our stories will continue to cross the gap, turning pixels into myths, myths into missions, and missions into memories. In this way, Mars is not only a world, but a process of seeing, questioning, and reaching outward. Now imagine the future decades when Mars ceases to be only a destination for robotic scouts and becomes a living extension of human civilization. Long before the first colony becomes self-sustaining, teams of explorers will establish research outposts near the anomalies that have fascinated Earth for generations. The choice of these locations will be practical. Access to ice, stable terrain, proximity to lava tubes for shelter, but also symbolic. Just as early settlers on Earth built towns at river crossings, temples on hilltops, and cities around sacred stones, so too will Martian pioneers cluster near the features that have already imprinted themselves on the collective imagination. Picture a base built at the edge of Gale Crater near the doorway. Its habitat modules glint in the thin sunlight, solar arrays stretch across the dust, and a small greenhouse bubbles with oxygen and humidity. Inside, scientists pore over maps of the region, planning traverses into canyons and up mesas. Outside, rovers creep toward the dark gap in the cliff that first inspired headlines on Earth. They will find nothing but rock, or perhaps they will find subtle layers of minerals, suggesting ancient groundwater, a signpost to a past climate capable of supporting life. Either way, their presence will convert myth into measurement. Farther north, another team lives in a pressure-sealed habitat, sunk into a lava tube nicknamed Glass Worm Alpha. The roof overhead is thicker than any steel vault, shielding them from cosmic rays. Its walls glitter with volcanic glass, older than any rock formation on Earth. As they expand the tunnel with inflatable modules, they discover branching side passages that wander deeper into darkness. The sense of standing inside a cathedral, carved by no hand, is overwhelming. Here, too, they install instruments, test drilling rigs, and search for ice or trapped gases. Living underground on Mars will feel at once like exile and sanctuary, a return to caves at the edge of an alien world. Above, orbiters relay high-resolution images to Earth, revealing still more anomalies beyond reach. New patterns emerge as seasonal winds rearrange dunes into shapes never before seen, while melting frost sculpts ephemeral sculptures. Each fresh photograph sets off waves of excitement back home, a ritual now as predictable as sunrise. Public forums buzz with speculation, while scientists race to model the processes at work. This interplay of myth and measurement becomes the heartbeat of exploration. Meanwhile, culture evolves. Children on Earth grow up with posters of the Shard or the Twin Peaks in their classrooms. Music videos are filmed using terrain data from Mars, transforming real topography into virtual landscapes. Science fiction writers spin tales of lost civilizations whose ruins line the canyons, while architects study Martian geometry for new designs back on Earth. In this way, the anomalies stop being anomalies and become part of our shared vocabulary. Landmarks in a mental map of the solar system. Mars also teaches humility in the face of deep time. Many of its most striking formations are older than multicellular life on Earth. The forces that shaped them have been at work for billions of years, unhurried and indifferent. Standing on Mars, a human lifetime feels like a flicker. Yet paradoxically, our presence there would fold a new chapter into that deep time. Footprints pressed into dust today might last for millennia, preserved by the planet's slow winds and lack of rain. Our exploration vehicles and habitats will become future anomalies themselves, objects of curiosity for whoever comes next. From this vantage, the anomalies we debate now, faces, pyramids, spirals, glass worms, spiders, take on a different meaning. They are not just puzzles, but invitations to think on planetary scales, to widen the frame of history beyond human civilization. They remind us that worlds evolve, climates shift, surfaces reshape, and that time dwarfs intention. In that vast perspective, even myths have their place, as tools we use to reach beyond the limits of our own experience. As the decades pass, a true Martian society begins to emerge, and with it, an entirely new relationship to the anomalies. What were once distant photographs become familiar landmarks, woven into the daily life of settlers. Children in domed classrooms learn their geography, not from maps of Earth, but from maps of Valles Marineris, Gale Crater, and the Tharsis Bulge. They grow up with lullabies about the Shard, stories of explorers entering the doorway, and festivals held under the twin shadows of the peaks. In this new culture, the anomalies cease to be mysteries and become heritage. The first pilgrimages begin. Colonists travel hundreds of kilometers across dust seas in pressurized rovers to stand at the edge of the Great Spiral Mound or to walk the perimeter of the Stone Ring. They leave footprints in the dust, plant flags, take photographs that echo the images once transmitted from orbit, but now infused with human presence. Just as cathedrals in Europe became destinations for centuries of pilgrims, so too do Martian formations become focal points for rituals of meaning and continuity. Some settlements adopt the names of anomalies. Others build their architecture to echo Martian shapes: hexagonal floors, spiral courtyards, shard-like towers. Meanwhile, science marches forward. With human crews able to drill deep cores and deploy massive rovers, the geological story of Mars is rewritten in detail. Data confirms the planet once had oceans, sustained a thick atmosphere, and perhaps even hosted microbial life. Fossils of ancient stromatolite-like structures are found embedded in clay layers beneath the ice. This discovery electrifies not just science, but philosophy. Suddenly, the anomalies gain a new dimension. They are no longer just strange formations, but part of a world that genuinely bore life. The Ring of Stones may still be an impact feature, but now it is an impact feature on a living planet's surface, carrying new significance. In turn, culture responds. Art, literature, and ritual shift to reflect the discovery. A Martian Renaissance begins, where the once hypothetical civilizations of pulp fiction are replaced by actual reconstructions of a microbial biosphere, a real story of survival and extinction written into the rocks. The myths of canals and faces transform into myths of ancient oceans and bacterial mats. Mars ceases to be an empty mirror of human longing and becomes a true other, a world with its own biography, older and stranger than ours. With time, the anomalies and the settlements around them merge into a hybrid landscape, part natural, part human-made. Domes are built inside lava tubes. Hexagonal agricultural plots echo the polygons of the high plains, and communications towers rise like shards against the salmon sky. Where the glass worms once shimmered alone, now entire cities are embedded underground, their entrances marked by airlocks carved into the rock. The doorway in Gale Crater becomes the face of a new science museum built into the cliff. The Shard hosts an observatory on its flattened summit, its thin atmosphere allowing telescopes to see stars with unprecedented clarity. In this world, the myths of Earth take on new forms. Festivals honor the arrival of the first humans at each anomaly. Children reenact the landing of the Pathfinder rover or the first descent into a lava tube. Poets write epics about the spiders awakening each spring at the poles. Even in everyday speech, Martians use the anomalies as metaphors, as hidden as a skylight, or as patient as the Shard. Slowly, a new mythology emerges, rooted not in speculation, but in lived experience. Yet even with all this familiarity, Mars retains its capacity to surprise. New anomalies are discovered by deep radar mapping, vast caverns beneath Olympus Mons, hidden lakes of briny water, strange magnetic anomalies hinting at a partially molten core. Each new find restarts the cycle of wonder and speculation. Colonists still gather around new images, debating their meaning, proposing theories, weaving stories. The planet remains not just a home, but a teacher, a constant reminder of nature's scale, time's depth, and the enduring mystery of the cosmos. Over generations, these practices create a distinct Martian identity. People born on Mars feel the anomalies in their bones, the way Earthlings feel mountains and oceans. They navigate by ridges and spirals, not by rivers and roads. They celebrate the return of the polar spiders, the way Earth celebrates spring blooms. In this way, the anomalies evolve from puzzles into cornerstones of a civilization. Pull back even farther, centuries from now, and Mars appears from orbit as a patchwork of domes, tunnels, solar fields, and restored ecosystems. Terraforming has begun in earnest, releasing greenhouse gases into the thin air, thickening the atmosphere, warming the planet. Small seas glint in low basins. Hardy lichens creep across sheltered rock faces. Above this emerging biosphere stand the anomalies, now ancient monuments not only of geology, but of the earliest age of exploration. Visitors arrive from Earth and beyond to see them, to stand at the spiral mounds, to gaze up at the shard, to dive into the glass worms, to watch the polar spiders awaken. Museums display the first photographs taken from Viking, Pathfinder, Curiosity, Perseverance, and the many missions after. Children play on playgrounds shaped like the face of Cydonia, though now it is just a hill, its myth retained as heritage. The Twin Peaks host observatories linked by suspended bridges, a literal gateway to the stars. Meanwhile, scientists compare the anomalies of Mars with those of other worlds. Icy moons of Jupiter and Saturn reveal parallel mysteries: ridges on Europa, spirals on Enceladus, plumes on Triton. The study of anomalies becomes a discipline in its own right, blending planetary science with psychology, semiotics, and cultural history. Why do some shapes recur across worlds? Why do we read intention into them? How does perception shape discovery? Mars, once the testing ground, becomes the template for how we approach the unknown across the solar system. Through it all, the red planet retains its aura. Even as seas form and air thickens, its sky remains tinged with salmon, its rocks rusty with iron. The anomalies stand as anchors to a deep past, a time when humans first reached beyond their cradle to touch another world. They remind future generations of the patience of exploration, of the way myths and measurements intertwine, and of the endless capacity of a single planet to provoke wonder. In this sense, Mars will always be more than a world. It will be a story, a living story, passed from one generation to the next, a journey through time as much as through space. Far in the future, when the chronicles of Martian settlement are written, historians will look back at the first blurry photographs of the face, the pyramid, the doorway, the glass worms, and see not naive mistakes, but the opening verses of a much longer epic. They will note how these images ignited a global fascination, how that fascination pushed funding, how the funding built missions, and how the missions built a bridge of technology, knowledge, and culture between two worlds. In this way, the anomalies that once stood for mystery will come to stand for the birth of a new planetary civilization. Imagine a grand library carved into the cliffs of Valles Marineris. Its galleries run for kilometers, cut directly into stratified rock, their ceilings supported by pillars of untouched stone. Holographic exhibits recreate the moment each anomaly was first seen, the debates that followed, the eventual ground truth established by explorers. Children walk among models of the Shard and the Twin Peaks, learning how geology can mimic architecture and how human curiosity can mimic faith. Outside the library, a terrace overlooks the canyon, where drones drift on thermals, and far below a thin ribbon of meltwater glints like a misplaced jewel. In this world, the myths of Mars have not vanished. They have matured. No one believes the face was carved by aliens, but everyone understands why it mattered. No one sees the spiders as literal creatures, but everyone knows they are a living heartbeat of the planet's polar cycle. The anomalies have become more than features. They are symbols of our capacity to be surprised, our willingness to invest decades of patience into unraveling a question, our ability to imagine futures bigger than ourselves. And yet, even in this far future Mars, new enigmas arise. Terraforming uncovers buried layers of ice mixed with dark material, hinting at episodes of climate far stranger than we thought. Ancient meteorites embedded in glaciers reveal isotopic signatures inconsistent with known solar system bodies. Deep drilling beneath the spirals finds mineral veins that could only have formed under pressures and temperatures unknown on the surface. Each discovery launches a fresh round of speculation. The planet refuses to settle into a single narrative. It is always one layer deeper, one question further. Above it all, human culture adapts. Festivals, poems, and holidays commemorate not just landings, but questions. Day of the first face photo, Festival of the glass worm descent, Week of the Twin Peaks alignment. Artists draw on Martian geometry to design public squares back on Earth. Schools teach anomaly literacy as a way of training students to think critically, yet imaginatively. The anomalies have become an educational tool, a philosophical touchstone, and an artistic muse. Standing at the rim of a spiral mound at dusk, with thin air glowing under a pale sun, a future traveler feels the same shiver of recognition that the first people felt looking at Viking images on flickering CRT screens. Despite centuries of knowledge, the sensation endures. You are part of something larger, an unbroken thread from curiosity to discovery, from shadow to substance. Mars, in this moment, is not merely a planet. It is a living testament to the human need to explore, to question, and to find meaning in the vastness. And so our long voyage across Mars draws to a gentle close. We have flown over rings of stone and spirals of dust, past pyramids and glass worms, walked in imagination through doorways carved by wind, and drifted above the polar spiders awakening each spring. Each formation, whether born of geology or nurtured by our imagination, has acted as a beacon calling us outward, a reminder that mystery still lives just beyond the horizon of certainty. Standing at this point, looking back over the vast terrain of ideas, we see how every anomaly became not just an image, but a bridge between data and dream, between our past myths and our future explorations, between a silent world and the stories we tell to make it speak. Mars remains what it has always been, a patient teacher and a mirror, reflecting our desire to find meaning, to explore, and to connect across unimaginable distances. As you breathe out and let the images settle, know that this journey has been only a prelude. The real exploration lies ahead, in the steps yet to be taken, in the questions yet to be asked, in the new mysteries waiting to be revealed. The red planet will continue to whisper its riddles, and we will continue to listen. Thank you for traveling across this alien world with us tonight. Until we meet again on another path through history and imagination, remember where you began this voyage. at Journey Through Time, your portal to stories that stretch across worlds, across eras, and across the endless curiosity that defines us all.